In our last class, we talked about linear inequalities in two variables, x's and y's, and we were given possible solutions, and we tested them out by substituting in the variables x and y into the inequality to see if the statement was true. We'll start with substituting 2 for x and -3 for y. We then simplify and we get 10 plus a -3. We don't know if that's greater than 10. Well, 7 is not greater than 10. That's a false statement. So our conclusion is that 2 -3 is not a solution. We're going to replace -2 for x in our next problem and y with 4. And we're going to see if that results in something that's less than or equal to 8. I have -4 plus 12. And that gives me 8, and 8 is less than or equal to. With that equal to sign, that makes this a true statement. If that equal to sign was not there, it would not be true. So then this is a solution. Let's practice a few more. 5 times -1 minus 2 times 5. Is that greater than or equal to 9? I've got a -5 minus 10. And I get a -15 is greater than or equal to 9, which is false. Once again, not a solution. In this problem, I'm replacing x with 2 and y with 3. Just taking that ordered pair, substituting it in, and I get 8 plus 3. Well, 11 is not less than 11. This is a false statement. So, not a solution. Here's a third one for you to try, and we'll go over that one in our session. Substitute in your x and y and see what that results in. So on to the graphing. The graph of a linear inequality in two variables is a half plane. We're going to actually be graphing the line the same way we graphed the lines for linear equations, and then we need to do some shading. Some of the things we'll do include graphing our y-intercept first, using the slope to find additional points, and connecting those points. This boundary line could either be a solid line or a dashed line. If it's a less than or equal to, if it's a less than or greater than inequality, we'll have a dashed line. If the inequality is less than or equal to or greater than or equal to, it will be a solid line. From there, we need to decide which portion of the boundary line we need to shade, and then we'll test out a point to find out which side to shade. Here's our first example. Now I've already graphed it, so I have that hidden for a moment because I'm going to talk about the steps. When we're doing this, we first want to be sure that the inequality is written with the y isolated on the left, and this one is already there. Now technically you can consider this an equation as you're graphing because you want to identify your slope, which is 2, and your y-intercept, which is -3. As we did with the equations, we're going to graph the y-intercept -3, use the slope to find additional points. However, this time we're going to extend that line across the entire coordinate plane, so we've got two distinct parts. Then, because this one has a greater than symbol, it's going to be a dashed line. So when we graph it, it will be dashed. And then we'll test a point to see the shading. Here's what it looks like in the graph. I start off by graphing my y-intercept, which is a -3. There's my point. I'm now using my slope, which is 2. I'm going to go up 2 over 1, up 2 over 1. And as you see, I'm extending this the entire length of the coordinate plane. Why? Because we need to create this two-sided plane. We're now going to test the point 0, 0. What does that mean? I'm going to go to the original inequality. Y is equal, I'm sorry, not is equal to, it's an inequality. Y is greater than 2x minus 3. We want to test a point that doesn't fall on the line, and the origin is the best one because it cancels a lot of things out here. So I'm going to end up with the result that 0 is greater than negative 3. That's a true statement. 0 is greater than negative 3. My origin is here, so I shaded the entire half to the left, which included the origin. And there is your first example. My second example I've already graphed as well, so let's just look at the steps before we get there. I'm going to graph it the way I graph an equation. I'm going to identify my slope. I'm going to identify my y-intercept. And then we'll test out this point. So let's test it out before we actually see it. So this way I don't give away any secrets here. I'm going to be testing out 0, 0. 0 is less than or equal to, and then I'm replacing this into the inequality. And this says that 0 is less than or equal to 4, which is another true statement. If it's a true statement, then I'm going to shade with the origin. Let's take a look at my graph. How did I start graphing this? With my y-intercept. 1, 2, 3, 4. There's my first point. My slope was a negative 3. It's counting down 1, 2, 3 over 1. If you notice, I extended this line the entire length of the coordinate plane. I tested out my point 0, 0 already, found out it was true, and here is my origin, which told me to shade everything on that side that included the origin. That means that all of these ordered pairs would make this a true statement, and I'll prove that in our next session. This one is not written correctly in the fact that we have an isolated y, so let's divide everything by 2. Y is less than or equal to 2x minus 3. Let's identify our slope. It's 2 over 1. Our y-intercept is negative 3. Here we're going to go through the whole process together. We'll start by graphing our y-intercept, counting down 1, 2, negative 3. My slope is a positive 2. I'm going to count up 1, 2, and over 1, 1, 2, and over 1. And as I said before, we want to extend this the entire length. Here's where, if you're doing this on paper and pencil and not on the computer, I highly recommend you use a ruler so that you can connect these points as neatly as possible. Now I'm putting a solid line. Why? Because this was a less than or equal to sign. So this became solid. And again, I should take this all the way up the entire length. Okay. We need to test out the point 0, 0. So I've replaced 0 for y and 0 for x, and it says 0 is less than or equal to negative 3. Well, that's a false statement. All right, 0 is greater than negative 3. The origin is here, so that means we will shade everything on the opposite side of the origin. And we'll be doing many more of these in class, but this should give you a good head start on how we're going to be graphing linear inequalities in two variables.